Hey, good morning, everybody. This is Mr. Aynesworth, and we're going to get into part 2 of lesson 1 here in Unit 7, talking about the tangent function and how it can be modified from the parent, which is obviously y equals tangent x. We did that in the first video. Here, we talked about how we can modify a or change a while keeping b equals 1 and see the effects. And we found out it was a vertical stretch and it affected the y values, and it did not affect the period of tangent, which was pi. And we did that. We analyzed 3 different functions. They're here. So we analyzed the tangent function, and then that's the parent, 2 times tangent, and then 1/2 times tangent, and they all had the same period. The only thing is that they were stretched out vertically, okay? And then we analyzed a few things where it was concave up and down, and so on. And I just noticed something here. I wrote down closed intervals for where it's concave up and down. These should be open intervals. So I'm going to fix that. All right, so fix this right here. These should be open. So go back into your notes, and these should be open intervals here. So let's get started. Here we go. This is Desmos required. We're a technology class. We all have iPads, so here we go. So we want to take a look at we know what the tangent function looks like. Okay, this is the parent. What does tangent of 2x look like? And what does tangent of 1/2 x look like? What is b when b equals 2? Okay, the b value is 2 here. And then here now, b is obviously 1/2. All right, what is when you multiply the angle or the input by a number other than 1, what does it do? Does it change the period? Does it stretch it horizontally, vertically? Does the period stay the same? We gotta analyze all those things. So we're going to start off by taking a look at tangent of 1/2 x. We're going to go to Desmos, and then we're going to draw it by hand, actually. And I'll show you what the important parts of it. We're going to analyze where it's undefined, where the vertical asymptotes are, which will help us with the domain. And then we'll talk about the range too as well, okay? We're only going to be able to do sketch 1 period here, so change it from 2 to 1. You'll see why here in a minute. Okay, so let's go to Desmos here. And let's type in your first function here, tangent of 1/2 x. So let me grab my lesson here. I've already, I keep my work, and I encourage you guys too, to keep your work in Desmos. Just save it as a file. You obviously have to set up an account for that. Okay, so what function do I already have in here? I have something graphed. Oh, check this out. Okay, so notice that I have y equals 1/2 x already typed in. You guys should know how to do this, and you should know how to adjust your x-axis here and put your function in. So I'm going to go full screen here so you guys can see it a little bit better, so we can take a look at this. The question is, like, where are the asymptotes for this thing? And so, of course, when you're discovering this stuff, you don't know at first, right? But if you look at it, if you take a look at a point on the graph, so we're going to just grab a point on the graph here, you notice that it's going vertical here, and when it does that and it approaches the vertical line, then an asymptote exists, and it sure looks like there's one at negative pi. There's another one right here. It sure looks like there's one at positive pi, and there's another one that looks like here at 3 pi, okay? Odd multiples of pi. Ooh, odd multiples of pi. So let's put those in. So go ahead and type in x equals negative pi, and x equals pi, and x equals 3 pi. I've already done this. I've also showed you guys how to change it to a table by using the gear up top. So just to recall here, you could click on the gear and you could change it to a table and then put your angles in. We did that in our first lesson, so you should know how to do that. Also, all the asymptotes should be red dotted lines. So what you do is you click on the color, and you have a choice of colors, make them red, and make it from solid, make it dotted, okay? Do that for all your asymptotes. They should be dotted lines because they're imaginary lines that the function approaches. And then I also showed you guys how to click on the gear in the upper right, and you could change your axes. So here I'm going to do it again. So let's go from negative 2 pi, all right, to, I don't know, 3 pi might be good. See? And then we change in the step is how you want to label your axis. So I'm gonna change this one to pi halves. So pi over 2, pi halves. right here, and notice what happens, okay? It shows you where all the halves are. 1/2, half pi, 2/2 pi, 3/2, 4/2, 5/2, and so on, okay? And it shows you where the points are being plotted. So notice that the table here has some points. They graph them for you, which is really, really cool. And this is important because these points on the graph are the points you plot when you do this by hand, okay? So make a table, click on the gear, put those values in, pause the video if you need to, all right? And so make it like this, and then go ahead and screenshot it, and then you can bring them in, okay? So you guys, this is all iPad stuff. You guys should be good at all of this. I've done this a million times before. We select copy and delete, and then all you have to do is bring this into your lesson here. And I already did. You just press and hold off to the side. Okay, I'll just repeat it here. Click on the text box, press and hold, and you should be able to do it. Come on. Oh, there we go. Just press and hold, and the paste icon comes up, and then voila, your graph appears, right? Okay, now I already have my graph in here, and I expect you guys to do the same. So when you submit your work, it should look like this when you're done. There should be screenshots of all your graphs annotated, when you submit your work. So we do a really good job of that. Okay, so what we want to do is describe the domain, all right? And the domain depends on the vertical asymptotes where it's undefined. So this function is undefined at negative pi, 3 pi, 5 pi, odd multiples of pi. So that's the first thing. So the domain is all reals except where it's undefined. And it's undefined at all these points where the asymptotes are. So I can say that my domain, okay, all reals except so negative pi. You can just list a few. Negative pi, 3 pi, 5 pi. Okay, odd multiples of pi. And so you say x cannot be equal to pi plus, odd multiples of pi. So k, well, actually, wait a minute. We got to talk about the period. Plus multiples of the period. So let me pause here. What's the period? What's the period? Well, it's the distance between the vertical lines, right? So between negative pi and pi is a distance of 2 pi, all right? So now the period here is 2 pi. Well, how cool is that? So it did change the period. 1/2 did change the period. And that's something that we need to recognize here. So give me a second here. Got a little discombobulated. All right. And so, okay, so what we have here, okay, so we have a period of 2 pi, and so it's going to be x can't be equal to pi, right? Pi, where to go? Oh, okay. Plus multiples of the period. So plus multiples of the period, which is 2 pi. Notice that from negative pi to pi. Sorry for my little delay right there. So this is plus 2 pi and then plus 2 pi. This is called multiples of the period. Multiples of the period, because this is a periodic function, right? So you've heard me say this, but the way you write it mathematically, you say x is not equal to pi plus multiples of the period, which is 2 times k pi, or you can say 2 pi times k, or k 2 pi, however you want to write it. Okay, this is called multiples of the period. Okay, and you have to define k. K is an odd integer. Notice it goes 1, 3, 5, 7, and so on. Okay, so odd integer. Okay, so when k is 1, you get 2 pi, you add 2 pi. When k is 2, you add, or excuse me, k is not 2, k is odd. So 1, 3, 5, and so on. So, well, you know what? We don't have to worry about that. We don't have, it's just, it can be just an integer. You know what? Let me back up. God, you know, that's a mistake right there. Sorry, k is just an integer. Okay, so k can be any integer, all right, plus or minus 1, plus or minus 2, plus or minus 3, etc. You guys know what integers are. Okay, so now what we do is we go back over here and graph it. So I'm going to just put it side by side, and we want to graph a period. So here's what you do. You got to graph the asymptotes. One's at negative pi and one's at pi. All right, so let me zoom in here. So here's negative pi. So you use dotted lines to do this. Put them in red as well. And this is part of your mastery here, guys. You're going to have to graph it by hand, like all the other functions. All right, and so when you do this, you put your asymptotes in, and then you plot 3 points. Plot 3 points, okay? Which points are they? Well, let's go back to the graph. Okay, so I'm talking about these 3 points here. So negative pi halves comma negative 1, 0, 0, pi halves comma 1. All right, and notice that they repeat in the period. So if you had a graph multiple periods, well, guess what? You just repeat these. You just shift this to the right, and then you shift it. So shift, okay, 2 pi radians, because that's the period, and then you just shift it. So drawing multiple periods is easy. You take those 3 points and just put it in the new period. Shift it to the right, shift it to the right. Okay, there we go. And now, so let's plot them. So pi halves comma negative 1 here, 0, 0, pi halves comma 1, and then you sketch this bad boy. Okay, so here we go. Okay, there we go. And then if you want to draw another period, you could. So again, you're going to be plotting 3 points. Okay, these 3 points right through here, draw your asymptotes. And then you can answer all these questions. All right, so let's answer the questions here. So we know the period of tangent. What's the period of tangent? We know that. Okay, it's pi, because the distance between negative pi halves and pi halves is pi. So the period there is pi. Period of 2 times tangent, we haven't done that yet. Period of 1/2 x, well, guess what? Okay, so the period here is from negative pi to pi is 2 pi radians, so 2 pi here. Oops, 2 pi over here. Haven't talked about 2x yet. We'll get to that in a minute. All right, and then we can answer these questions off to the right. I'll get to 2x here in a minute. So where is it? What's the domain? Well, all rails except. So here we go. All rails except, all right, not equal to, all right, pi plus multiples of the period, which is 2k pi, where k is an integer. Okay, now if you don't like that notation, you could just say x not equal to, and then you can list a few out. You can say negative pi, comma, 3 pi, comma, 5 pi, etc. ... Okay, so if you want to write it like that, I'll accept that too. The range, well, it goes infinitely up and down, so the range is the set of all reals. Okay, where's it concave up? Well, let me see, this is 0. From 0 to pi, it's concave up. So that's from 0 to pi. Where's it concave down? So go to the graph and label. All right, concave down from negative pi to 0. So negative pi to 0. You always go left to right. Okay, left to right. So this interval here, actually, from here to here is from negative pi to 0. And then 0 to pi in this range right here, this is the interval from 0 to pi. Always read it from left to right. Okay, so now what we need to do is analyze the tangent of 2x. All right, so we now know how to find, well, actually we shouldn't be able to find the period. So the period for sine and cosine, so the sine of x, okay, and cosine of x, we found the period by taking 2 pi, the period of the parent function, divided by b. All right, for tangent, it's different. For tangent of bx, all right, we can't do that. The period of tangent is pi, not 2 pi. So for our new function here, for tangent only now, we're going to take pi divided by b, which we take the period of the parent function. So this is parent function period, parent function. And again, this 2 pi is for the parent here. So you always take the period of the parent function divided by b. So for us right through here, for this one, when b is 1/2, so I'm going to do it here, period is going to be pi divided by 1/2. Well, guess what? Take pi times a reciprocal. Reciprocal of 1/2 is 2, and we get 2 pi, which is what we found out in Desmos. All right, we talked about that. Okay, so now, but you can now predict what it's going to be before you even use a graphing calculator, haha, which is kind of nice. All right, so the way to find the period now is to take pi divided by b. Okay, because b affects the period, and that's what we're going to say down here in the conclusion. All right, b affects the period. So I'm going to put this in red. So b affects, all right, the period. Okay, so how do you calculate that? Well, p, for period, is equal to the period of the tangent function, which is pi, divided by the coefficient. Okay, so that you have to know. Now, if b is less than 1, it's going to stretch it out horizontally. And if b is bigger than 1, like here, this is going to be, b is 2 right here, it's going to be something else. So let's go to Desmos again. Here we go. All right, and we type it in. So before we do this, click on save. All right, turn off your colors. We're going to switch functions here. So you don't delete any of your work, you keep it. All right, so type in y equals 2 times tangent of 2x, where you're taking the angle and doubling it. And let's see what happens with this function. All right, so here we're going to need to change click on your wrench and change the step to pi force, pi divided by 4, so we can see things more clearly, okay? So notice the asymptotes aren't in there, but if you look at your function, right here, just take a look at one, it approaches a vertical line again, okay? And guess what? It approaches negative pi force when you go way up. And over here on the second one here, it approaches positive pi force when you go up. And then on the third one, it approaches 3/4 pi. So we definitely have new asymptotes here. So when b is 2, which it is up there, we have new asymptotes. It affected the period. But what's the period? Well, type in your asymptotes first. So type these in and make them all red dotted lines. Use your gear. So click on the gear, click on the color, select red and dotted, and voila, you get vertical asymptotes. Okay, so now put in your points in here too. So notice that I put in some angles. You want the distance between 0 and pi force is pi eighths. 1/2 of a fourth is an eighth. So you know what? Let's click on here and let's go step pi eighths. Let's change this to pi divided by 8 so you can see. Aha! Okay, so there we go. Okay, so let's zoom in here. So look at this. So negative pi is coming -1, 0, 0. These are the points that you want to plot. Okay, so pause the video here if you need to. Convert this to a table, put your angles in, put your asymptotes in, and then when you're ready, come back to the video here and check your work. All right, and always press save when you're entering and changing the Desmos functions. Save all your work. Okay, so let's go ahead and screenshot this. Let's bring this in and then use it. All right, so here we go. Let's go back to our lesson here. Let's find the tangent of 2x. So this is what we have. All right, and so we have new asymptotes here. So let's analyze this and then before we answer the question. So here, the distance between the vertical lines, these asymptotes, is the period. Okay, so get out red pen and let's analyze the period. So the period is this distance right here. All right, so from negative pi force to 0 is pi force distance. And then 0 to pi force is obviously pi force. And 1/4 of pi plus 1/4 of pi is 2/4 or 1/2 pi. So the period is pi halves. It's 1/2 of pi. 1/4 plus 1/4 is 1/2. Okay, again, so we have a new period here. So when b is 2, which it is right here, this is b value, all right, the period can be found by taking the period of the tangent function, the original parent right here, and divided by 2. So by b, which is obviously pi divided by 2. So now our method of calculating the period by taking pi divided by b is working, no matter what b is. But again, it's pi divided by b, not 2 pi divided by b. It's the period of the parent function divided by b. So keep that in mind. Let me see, what else? Oh, now we have a new domain. So its domain is all reals except these asymptotes. So the domain, okay, all reals except negative pi fourths, comma, pi fourths, comma, 3/4 pi, plus multiples of the period, which is plus multiples of this pi halves. So you go dot, 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 or you can say x is not equal to all these values. So negative pi fourths, comma, pi fourths, and then 3 pi fourths, and so on. Comma, dot, dot, dot. Okay? Or you can write it mathematically, which I'll do here in a minute. And the range is infinite. Okay? Also, you can see where it's concave up and down. So it's concave down from negative pi fourths to 0. So it's concave down here, concave down from negative pi fourths to 0, negative pi fourths to 0. And then it's concave up from 0 to pi fourths. So concave up from 0 to pi fourths. Look at that. So you annotate your graph so you know what you're doing, all right? And that's just for one period only, of course. So let's bring it over here and let's write down what we just have. Okay, so just keep that, let's see, zoom out, there we go. All right, so concave up from 0 to pi fourths, 0 to pi fourths. Concave down from negative pi fourths to 0. Okay, what's the domain? I said all reals except pi fourths plus multiples of the period. So pi fourths plus multiples of the period. Now the period is pi halves. So the way you write this guy is plus k pi halves, okay, where k is an integer. Okay, so k equals integer. Or, like I said, if you don't like that, okay, if it doesn't make any sense to you, which sometimes it doesn't for people, okay, just go negative pi fourths, comma, 3 pi fourths, comma, 5 pi fourths, and so on. And you go dot, dot, dot. Okay, that's the same thing. Okay, range is the set of reals. Okay, so now I think that's it. So look at that. Look what your homework should look like here. All right, so you have screenshots of all your work. The graph is totally labeled. And it's looking good. Okay, look at that. That's pretty damn awesome. All right, so we just did a little discovery here. What does the lead coefficient A do? We have a vertical stretch. All right, it doesn't affect the period at all. And then B affected the period big time. We take the new period for tangent is now pi divided by B, whatever B may be, if that makes sense. Okay, and then the rest is on you. Right here, you can check your instructor's notes. This is review right through here. So I'm not gonna, solve each one right here, but just go ahead and work through it, check your work. And if you have difficulty with any of this, obviously see me in class, okay? Because I'm not gonna spend 2 hours running a video on every single little detail. You guys got to work on your own, check on your own, work hard, work with other classmates, all right, and come get help when you need it. All right, take care, you guys. This is Aynesworth. I'm out of here. Bye-bye.